In this lesson, we're going to focus on simplifying derivatives. So let's start with an example problem. What is the derivative of this function? X cubed times 2x minus 5 raised to the fourth power. Now, for this problem, we need to use the product rule. And here's the formula for that. So the derivative of f times g is the derivative of the first part, f prime, times the second, plus the first part times the derivative of the second part. So we can clearly see that f is x cubed and g is 2x minus 5 raised to the fourth power. Now f prime, the derivative of x cubed, that's going to be 3x squared. And to find g prime, we need to use the chain rule. So the derivative of 2x minus 5 raised to the fourth power is going to be 4, and then keep the inside the same, 2x minus 5. Using the power rule, subtract this by 1, and then differentiate the inside function 2x minus 5, which is 2. So now let's apply this. So it's going to be f prime, which is 3x squared, times g, which is 2x minus 5 raised to the fourth power, plus f, that's x cubed, and then g prime, which is 4 times 2, and that's 8. So it's going to be times 8, 2x minus 5 cubed. Now, what should we do once we get to this part? How can we simplify this expression? The best thing to do right now is to take out the GCF, the greatest common factor. And so we can factor out an x squared, and we could take out 2x minus 5. At least 3 of them, because there's 3 here and 4 here. So we got to take out the lower of the two numbers. So if we take out x squared and 2x minus 5 to the third power from that expression, what's left over? So the x squared is gone. We took out 3 of these, so there's going to be 1 left over with a 3 in front. So it's going to be 3 times 2x minus 5. Now for the next one, we took out x squared, so there's an x left over. We have an 8, and we took out all 3 of 2x minus 5s. So it's going to be plus 8x. And that's all that's left over for that term. Now all we need to do is distribute the 3 and combine like terms. So 3 times 2x, that's 6x. 3 times negative 5, that's negative 15 plus 8x. And now let's add these two. So we're going to have x squared times 2x minus 5 to the third power, and 6x plus 8x, that's 14x. So this is the final answer, fully simplified. Now let's work on another example. Feel free to pause the video if you want to try it. What is the derivative of x squared times the square root of 4 minus 9x? So once again, we need to use the product rule. And so you could rewind it if you need to look at the formula. But the gist of it is that you need to differentiate the first part of the function, which is x squared. So that's 2x. And then keep the second part the same. So we're going to rewrite the square root of 4 minus 9x. Plus, keep the first part the same. And then differentiate the second part. Now let's focus on that. Because to differentiate this, we need to use a chain rule. And before we do that, we need to rewrite it as 4 minus 9x raised to the 1/2. Now, whenever you're differentiating a composite function, let's say if you want to find the derivative of f of g of x based on a chain rule, you need to differentiate the outside part of f and then keep the inside part, the inside function g of x, the same, and then multiply by the derivative of the inside function. So that's the main idea behind the chain rule. So first, let's differentiate the outside part of the function by using the power rule. So it's going to be 1/2, and then keep the inside function g of x the same, so 4 minus 9x, and then subtract the exponent by 1. So 1/2 minus 1, or 1/2 minus 2 over 2, that's negative 1 over 2. And then multiply by g prime of x, the derivative of the inside function. So the derivative of 4 minus 9x, that's negative 9. So that's what we have now. So I'm going to combine these two. So that's going to be times negative 9 over 2, and then 4 minus 9x raised to the negative 1/2. Now I'm going to rewrite this expression. So let's erase it first, and let's write it as a rational exponent. So it's 4 minus 9x to the 1/2. Now in this form, this is when you want to factor the expression, where you want to take out the greatest common factor. So we could take out an x from both terms, because they both contain an x. Now in the last example, we had 2x minus 5 raised to the 4th power in the first term, and in the 3rd power for the second. And when you're dealing with 4 and 3, you want to take out the lowest of the two numbers. So you take out 3. Now in this case, we have a negative exponent. So what should we factor out? 1/2 or negative 1/2? Well, negative 1/2 is lower than 1/2 on the number line. So because it's less, we need to factor out 4 minus 9x to the negative 1/2. Now, when you take out the GCF, if you want to find out what goes on the inside, divide what you had by the GCF. So if we divide 2x by x, the x variables will cancel and we're going to get 2. If we divide these two, we need to subtract the exponents. For instance, let's say if you want to divide x to the 7 by x to the 4. This is going to be x to the 7 minus 4, which is x cubed. So in this case, if we wish to divide these two, we're going to take 1/2 and subtract it by negative 1/2, which becomes 1/2 plus 1/2, which is a whole. So this is going to be 4 minus 9x raised to the 1st power, which is great. Now let's focus on the second term. Negative 9 over 2x squared divided by x, it's going to be negative 9 over 2 times x. And then if we divide these two, negative 1/2 minus negative 1/2, that's going to be 0. So this is completely gone. We took it out. So this is what we have now. So first, let's distribute 2. So this is going to be 2 times 4, which is 8. And then 2 times negative 9x, that's negative 18x. And then minus 9 over 2x. Now we need to get common denominators. So 18x, I'm going to multiply by 2 over 2. So it's going to be negative 36x over 2, and then minus 9 over 2x. So negative 36 minus 9 is negative 45. So we have 8 minus 45 over 2x. And then that's multiplied by x times 4 minus 9x raised to negative 1/2. What we can do at this point is take this term or that factor and move it to the bottom to make the negative exponent positive. So this is going to give us x times 8 minus 45 over 2x divided by 4 minus 9x to the positive 1/2. Now we can write the final answer as x times this stuff, and then let's convert this rational exponent into a radical. So that's simply the square root of 4 minus 9x. So you can leave your answer like this if you want to. But if you're told to rationalize the denominator, you can take it one step further. So if you need to do that, you can multiply the top and the bottom by the square root of 4 minus 9x. So you can also leave your answer as x, 8 minus 45x over 2 times the square root of 4 minus 9x divided by 4 minus 9x. So if you need to rationalize it, you can report your answer in this form, but if it's not necessary to rationalize it, this form is also acceptable. There's a lot less writing in this form.